Okay, so we're starting on lesson 33 today on page 235 in your book. Talking about decimals, we're going to compare decimals, and with that we'll learn about rounding those decimals up as well. And we're going to dive right into our first example in your book on page 235. It's asking us this question, and I'm learning how to use my board here, so bear with me a moment while I come up here and go to the text block and I type in the question that they're asking us. They are saying to arrange these three, and you have to put up with my mistakes, my typos. Arrange these three decimal numbers in order from, I think they want us to go from least to greatest. That's what they're asking us to do, from least to greatest. So we're going to take this, we're going to put this right up here, and we want to arrange those three decimals from least to greatest. Now, here's the numbers that we have that we're in fact working with. Let me get my pen back. Here we go. And we have these numbers. We have 0.13, make my point a little bigger there. We have 0.128, 0.128, and then we have 0.0475, 0.0475. So they want us to arrange the decimal numbers, not munbers, in order from least to greatest. And we look at these, and what you don't want to do is you don't want to say, well, I've got 1, 2, 3 numbers here, 1, 2, 3, 4 numbers there, 1, 2, 3, 4, 5 numbers there. So obviously the 3 is the least number and the 5 is the greatest. You don't want to do that. You really have to start looking from left to right and work your way over as if you were reading a book. So the first thing we see when we're comparing all these numbers is that there's only one spot to the left of the decimal. That's this spot right here that's being used, and they all happen to be 0, so these numbers really don't have any effect on which number is the smallest. So we go next, and that's going to be right past the decimal. We have a 1, and we have a 1, and we have a 0. So obviously 0 is less than 1, so 0 is the first number that's going to be listed, or this number here rather, that has a 0 listed first is going to be our smallest number because it has a 0. It has a 0, 0. This has 0, 1. This has 0, 1. So this is the smallest number. So the least number would be 0.0475. I hope you can see that. Now, so we've gotten rid of this one. Now we're dealing with these two. And we've decided that this is 0, 1 and this is 0, 1. So up till now they're both equal. Then we have 0, 1, 3. This is 0, 1, 2. 2 is less than 3. And if we covered up this 8 and it wasn't there, let's just pretend that it's not there, we have 0.13 compared to 0.12. Well, obviously 1,3 is greater than 1,2. This confirms it by the fact that 2 is less than the 3 in the sequence. So the next least number is going to be 0.128. Now, we've canceled that number out, and that leaves one number left. That leaves, of these three numbers that we had to choose from, that leaves 0.13, which, just because it's the last number left, it has to in fact be the largest number. So we write that down here and we have 0.13. So going in order from least to greatest, and it's just the opposite. See, they tried to fool you by having this number with 5 digits be like the larger number, where in fact, when we look at it, it's actually the smallest number, and the number that has the least amount of digits happens to be the largest number. It's not the number of digits, it's where they're placed by the decimal point. That's what makes the difference. Okay, so our next example that we have in the book on page 236, it wants us to compare these two numbers, and it's a problem that looks like this. It wants us to compare, if you can read what that says, 0.12, then it's got this big circle, to 0.012, 0.012. 1, 2. See if I can close that 0 a little bit better. 0.012. Which one's greater? Our choices are going to be less than, greater than, or equal to, and we have to find out which one's going to work for this in this equation or this sentence, comparing 0.12 with 0.012. You know, one thing you can leave it like this and just go left to right and say, okay, well, here's a 0 to the first spot left of the decimal. Here's a 0 to the first spot left of the decimal. So therefore, right now they're equal. Then you can come to the next number, which happens to be past the decimal, and we have a 0 and we have a 1. And you can instantly tell that this 0.1 is going to be larger than 0.0. So very clearly and obviously, the sign is going to be that sign, indicating that the 0.12 is greater than the 0.012. I hope you understand that and that makes sense. Okay, and now for our next example, example 3. It wants us to once again compare. So we're going to compare, and here's what we're comparing. We're comparing 0.4 and our little circle to put our answer in there with 0.400. Now, like I said before, one thing you have to make sure you don't do is don't look at this and say, well, you know, I have 2 numbers here and I have 4 numbers here, so therefore this must be bigger. That's a trick that can work but doesn't always, and you certainly want to never use that as a way to figure out greater than, less than, or equal to. What you want to do, you want to just compare like I did in the last problem, side by side, or what you can do also, you can stack them on each other and have 0.4 and then 0.400, and you can look at that and say, okay, let's compare. So let's do it that way. We see that the zeros to the left of the decimal, they're the same, so that's not going to be a factor. The decimal's right here. We have 2 4s, so they kind of equal each other out. Now an interesting situation occurs because we have a 0 here and we have nothing here. We have a 0 here with nothing here. But what you have to remember is when you don't see any numbers, you can actually put zeros in there if you really wanted to. So you can theoretically think of that as being a 0, like a phantom or a ghost 0, so I'm putting it in there very lightly, but it really is a 0 there. So the bottom line is that when you're comparing this, everything is equal all the way. There can't be a number greater than 0 up here anywhere because it would be present, it would be there. It can't be a negative number because you can't have 0.4, -1, -2. That doesn't exist. So what basically is happening, and the rule that you have to remember, is that when there's no numbers, and this gets a little technical, it has to do with significant figures, which you see mostly in your upper level sciences. It's kind of understood that there's zeros here already anyway, so you really have zeros there. So the bottom line is the 0 here and the 0 here are the same, they're equal. The 4 here and the 4 here is equal, and the 0 and the 0 that's here is really equal to the 0 and 0 that we don't see here. So our sign for this is going to be equals. 0.4 is in fact equal to 0.400. Not to confuse you, but just as an example, if you would have had a 1 over here, then you would have 4001 versus 4. Then the fact that there are zeros here all the way through that we just don't see anymore, and we have a 1 here, this would be a larger number, so then our sign would be 0.4 is less than 0.4001 because this has a counting number in it that this number over here, past 4, will never ever have. So I hope that makes sense and it doesn't confuse you. Alright, now we're going to get into the subject of rounding. We're going to have a chance to do some rounding now. So let's see how that works out for us, and hopefully we'll be able to make some sense of that for you. When we're talking about rounding,